Hey everyone, welcome back to another OneClass session. My name is Bassam, I'm an engineering graduate, and today I'm going to be guiding you through some math questions at the high school and the preliminary university level. So let's get started over here. Okay, so the first question we're asked is Harry wants to buy pencils and erasers. Each pencil costs 30 cents and each eraser costs 15 cents. So for a pencil, 30 cents. For an eraser, 15 cents. He wants to buy 30 items altogether with $5.25. So $5.25. That's our total. So I'm just writing some givens down based on the question and the statements given. How many pencils should be purchased if he wants to buy the most possible number of pencils? So we want to purchase the maximum number of pencils. And another important fact that's given, he wants to buy 30 items. So 30 items altogether. So pencils and erasers in total will be 30 items. So we'll say we'll define pencils as X, and we'll define erasers as Y, just to give the quantity variable for each component. So the pencil is described as X and eraser as Y. So here we can kind of set up some equations. The first being 30, so 30 cents times the number of pencils, so X, plus 15 cents times the number of erasers. So the total cost should be equal to $5.25, which is just 525 cents. So $5.25 is equivalent to 525 cents. Each dollar is 100 cents. Okay, so seeing that we have two variables, the most likely thing that we also have to define is another equation based on the given information. So the other important fact that is given to us is that we want to buy 30 items in total. So we're constrained to 30 items, so the total quantity of X and Y, so total quantity of pencils and erasers is 30. So we can see right away we're given two equations and two unknowns. So now we essentially just have to find the solution for each variable by just using algebra. So we'll start off, we'll rearrange the second equation. So y is equals to 30 minus x. And we'll substitute this into the first equation. So over here, into y over here. So the first equation will then be 30x plus 15 in brackets 30 minus x. And this will be equivalent to 525. The next value that we want to solve is, we want to expand this out, first. So 30x plus, so 15 times 3 is 45, and then we add the 0, so 450. And then 15 times negative x is negative 15x, which gives us, so I'll just double check this over here. So solving for this, we get 525 on the right side. We'll go on one more step, so we'll subtract 30x minus 15x. This gives us 15x. And then 525 subtract 450 is just 75. So knowing this, x equals So 75 divided by 15, so that's 15 plus 15 is 30, plus 2 more 15 is 60, that's 4, so it'll be 5. X will equal 5. So here we know that we can buy 5 pencils. So I believe the question is only asking for pencils. How many pencils should be purchased if he wants to buy the most possible number of pencils? So it looks like this is our answer. We can also solve for the number of erasers. So we buy 5 pencils. That means we can substitute x into this equation here. So 5 plus y equals 30. 30 minus 5 will be equal to 25 erasers. So let's just take a look at this solution provided in a little more detail. So here they start off defining the correct equations. They set y equals to 0 and x equals to 30. So here they're just testing for, let's say we bought 30 pencils, we would get x equal to 17 and a half. Or sorry, if we, x. Doesn't make sense. In the first equation, second equation becomes, so they substitute 0 for y. So they're saying if they bought 0 erasers, you can only buy a maximum of 17 and a half. So it seems like let's look at this a little further. So here they substitute in the equation correctly and they get 5. So they kind of did some additional steps that are unnecessary, but they got the right answer at the end. So solution is correct, unnecessary. Steps taken to get to final answer. Okay, let's get to the next question. Right, so how do you factor and simplify? So there's no question how do you factor and simplify? There's no really a question here, it's more of a concept. Let's look at the solution. So let's start off with this example because this is kind of what the solution attempts to solve. So I'm assuming this is kind of what the question is asking. So let's say we had an equation as follows: sine 4x minus cos 4x. Okay, so, and we're trying to figure out how can we simplify this down. So because we have a minus sign in the middle, we can see that this is a difference of squares. I'll clarify that by just rewriting this equation in a more simpler format. So we would have sine squared x squared minus cos squared x squared. So because we just kind of expanded it out, we can see now it's a little more clear why this is a difference of squares. And the equation that we would be using is this one, the one we're in on the side here. So a squared minus b squared is equal to a minus b, a plus b. So that's just the difference of squares equation. So moving on, we would get the following. So we would get sine squared x minus cos squared x times sine squared x plus cos squared x. Okay, so here, if we were to represent a and b values here, a would equal sine squared x, and b would equal cos squared x. And then when we're splitting them out, a and b, we have sine squared minus cos squared, and then a plus b again, so sine squared plus cos squared x. So using trig identities, we know sine squared plus cos squared, this just equals 1. So this kind of simplifies down. And we're left with just this component. We have to think of a trig identity that can help us simplify this down even further. So we can rearrange this to equal cos squared x minus sine. So we just factored out the negative in the beginning. Okay. And the trig identity that we have here is cos squared x minus sine squared x is equal to cos 2x. So actually it's not 2 cos, I believe it's just cos 2x. So let me just double check this. So usually you have a trig identities table that is useful to remember all the trig identities. Let me just pull one up right here so you guys can take a look. Just give me a second here. Alright, so here we can see cos 2 theta over here. So cos 2 theta is equal to cos squared theta minus sine squared theta. So that's the trig identity that we're using to simplify. Okay, so getting back to the question, we'll end up with negative cos 2x. I'll put this in bracket just so it's clear. So you can't simplify this down any further. That's kind of your final answer. So let's just double check this solution over here. So we update comp with the same final answer, negative cos 2x. Okay. So I believe here they provide another example. So instead of sine 4x squared, sorry, sine 4x minus cos 4x, they say cos 4x minus sine 4x. So it's also a difference of squares. So following a similar process, you can eliminate the cos squared x plus sine squared x. This is equal to 1. And then you end up with this, except you don't need a negative sign in the beginning because it's already in a format where you can convert it to cos 2x. So here's another example. So cos squared x plus sine squared x, to the power 6. A very important trig identity to remember is as follows. Probably one of the most important trig identities. Oops, let me just write that up here. So sine squared plus cos squared equals 1. So whenever you see cos squared plus sine squared or sine squared plus cos squared, you can right away say that 1 to the power of 6 is just 1. So see here, simplify 1 to the power of 6, 1 to the power of anything is just 1, and we get that answer. So correct explanation and examples. Great job. Right, so here we're asked for the square root of 64. So depending on what level you're at for this question, so the square root of 64 is plus or minus 8, because mainly because 8 times 8 is 64. Another way to think about this is kind of what can we divide by 64 to get to the 8? So we can divide 64 by 2. So we can start off divided by 2, so we can say 32. So if you know that 64, the square root of 64 is 8, you can kind of right away say it's plus or minus because of the square root. And you can kind of say that 2 times 32, sorry, it's being a little laggy. 2 times 32 is also 64. And then you can also say 16 times 2 times 2. So you can kind of split this up into factors of 2 and use it, evaluate for simpler numbers. Maybe you don't know what the square root of 64 is, so but you do know the square root of 16 is 4. So you can say 4, you can pull that out in front, and then 2 times 2 is just 4. And you know that the square root of 4 is 2. So you have 4 times 2, and that also gives you 8. So depending what the question is asking, usually use a plus or minus. Sometimes you'll use the positive value depending on the constraints. So here they provide other examples. So how do you find the square root of 144? Use a similar idea and simplify out to get 12. You can also see that positive 12 times positive 12 is positive 144, and then negative 12 times negative 12 is also 144 because the negatives cancel out. That's why we have a positive and negative over here, because we know that negative 8 times negative 8 is also 64. Great explanation. Okay, so the answer is correct. Solve the equation with rational expression. All right. So this is just an algebra question. So we'll start off here, just writing out the equation. So 3x plus 3. Let's just erase this. So there's multiple ways of starting off this question. I'll show you the best way to simplify kind of your solution. Then we have 2 over x plus 3. All right, so one way to start off is just to multiply both top and bottom of the x plus 3 on both sides by x minus 2 to get that common denominator. And you can also multiply the middle term here by x plus 3 on both on top and bottom to get the common denominator. So you can see that you could have a common denominator of x plus 3 multiplied by x minus 2. But another way to think about this question is to move terms around. So we can move this term to this side of the equation and then move this term to that side of the equation, because we already have a common denominator of x plus 3 in this term and x plus 3 in this term. Okay, so to start off, we know that 3, so we'll take the 2 on top here, and we'll say minus 2. Since we have a common denominator, we can just put all of this over x plus 3. And then this is equivalent to, we're going to move this term to this side. So we get positive 4 over x minus 2. And then the next step is we have 1 over x plus 3. 3 equals 4 over x minus 2. Okay, so we'll clear up some space up top. So because we added the two terms that had the common denominator in the beginning, we didn't have to really find the common denominator x plus 3 or x minus 2. So we didn't have to multiply by anything to, have the middle term have a common denominator with the rest. So we didn't really have to manipulate the common denominator as much. We just rearranged. And now here we can just multiply this over here, and then multiply this over here. And then we'll end up with x minus 2. So we're essentially just multiplying x minus 2 by both sides of the equation is equal to, similarly for x plus 3. So I'll write this below, x plus 3. Okay. And then we'll have x minus 2 equals 4x. Sorry, 4x plus 12. So 4 times 3 is 12. And then we'll rearrange here. So 4x and then minus x on this side. So we'll move this over to this side by subtracting x on both sides. That'll give us 3x on this side. And we'll subtract negative 12 on this side and negative 12 on this side. So we'll have negative 2 minus negative 12, which will give us negative 14. And now to solve for x, x equals negative 14 over 3. And that's our final solution right here. Okay, so let's just take a look at the provided attempt for the solution. So they use a similar process, so they don't find the common denominator right away. They just rearrange, and then you end up with x equals negative 14 over 3. So the solution is correct. All right, let's go to the next question. All right. So let's take a look at this diagram here. So in the diagram of circle O, M, triangle JKL, so the angle M is equal to 72. So we're talking about this angle here. what is the value of x? So x here, I believe, is defined as JOL. So if we have another triangle, JOL, that's the x angle. So let's redraw the diagram over here to better understand the question. So we have a circle over here. So this is a perfect circle. And then we have a triangle, like so. And we have the center of the circle. It's not quite the center. So somewhere okay. We have an angle here of 72. So this is M. 72. So 72, and then we have the triangle here is labeled J, K, L. So there's a point here that's tangent to the circle, and a point here tangent to the circle. And then we have something like this, and then we have the angle that's over here. Okay. So I'm going to erase the label for the angle X, just so it doesn't get in our way. So up here is supposed to be a J. So to find what the angle over here is, we have to relate the angle M to that angle. And one thing to note is from the center of the circle to tangent to the circle, we know that anything tangent to the circle will be a right angle. So right away, we've defined two angles that can help us out in relating M to X. The other thing that we have to do here is draw a line across. So this gives us, splits the four-sided polygon into two triangles. So we have two right angle triangles. We know for any one triangle, the angle has to equal 180 degrees. So the sum of all the angles of the triangle has to equal 180 degrees. Because we have two triangles here, we can multiply this by 2. So we know the sum of all the angles in the polygon, the four-sided polygon, should equal 360. So we have four angles here. We have one angle here, 72. So we can just put that right in. And then the next angle we have is 90. And then we also have another 90. And then we have angle X. So we have plus 90. Let me just write this a little smaller so it's all in one line. So we said we have 72 plus 90. So we have 90 twice, so we'll just multiply that by 2. Actually, this might get confusing, so I'll just leave them separate. And we also have X. So we can add up 72, 90, and 90. So 90 plus 90 is 180. And then adding on 72 should give us 252, I believe. So I'll just plug that into our calculator to double check. 172 plus 180. So 252. Yep, that's correct. We have plus X. Will give us 360. So we have X is equal to 360 minus 252. So we subtract 252 from both sides of the equation. And that will give us 108. So this is our final answer. The angle X will equal 108 degrees. Okay. So they follow So yeah, they define the same parameters here, and they say for the quadrilateral, the total angle should be 360, so similar to us, and then they evaluate for the angle JOL, which is just angle X as defined in the diagram above. So JOL, angle X is over here. And then you get the angle 100. So that's the correct answer. All right, so there we go. Right, so given a polynomial here, let's take a look at this image. So the polynomial is x to the power 5, 2x4. One root of this polynomial is 3i. Express p of x as a product of 5 linear polynomials. So essentially we just have to find the roots of this polynomial. So I'll write out the equation. Okay, so x to the 5, 2x to the 4, positive 6x3, 12x squared, and 27x. Okay. So we have x to the power 5 plus 2x power 4 plus 6 plus 6 x cubed, and then plus 12 x squared plus, sorry, not plus, minus 27 x, and then finally minus 54. And the question is telling us that one of the roots is equal to x is equal to 3i. So knowing this, because we have an imaginary root, we can also say that the conjugate is also a root. So whenever we have an imaginary root, we know that the conjugate is also a root. So imaginary roots are always expressed in this format. So a plus bi, and then the conjugate is always a minus bi. So in this scenario, we know that the conjugate of 3i is negative 3i. So actually, the question helps us infer two roots of this polynomial. So knowing that we have 3i and negative 3i as roots, we can write that out over here. So we know we have x plus 3i and we have x minus 3i. We can also simplify this even further to the difference of squares. So we can recognize that this is the difference of squares, and essentially get that to x squared minus 3i squared. So we don't need this bracket. Okay, so the difference of squares is just the standard formula. So any value a squared, let's say this is a squared minus b squared will give us a plus b times a minus b. So in this scenario, a is x and b is 3i. So once again, a squared minus b squared always equals a plus b times a minus b. So that's the standard formula for difference of squares. We can also define what I is. I is the imaginary number for the square root. I'll write that a little better. So the square root of -1. So knowing this information, we can kind of square the 3, which will give us 9, and we can also square the I. So the square of the square root of -1 will just give us -1. So here we can say x squared minus 9, so 3 squared, times I squared, which is just -1. So I squared is -1. And then since we have 9 times -1, we can just turn this into a positive sign. So we have x squared plus 9, and we know that we can factor that in to this polynomial to get the roots positive and -3i. So let's erase this down here. So we can use x squared plus 9 to do some long division between this polynomial and x squared plus 9. So I'll erase this over here just so I don't have to rewrite the equation. I might have to rewrite this a little smaller. Okay, so let me just clear the board. Okay, and essentially we want to do long division of the following. Okay, so we're going to divide x squared plus 9 into the initial polynomial. Because we know we can divide this into the polynomial and get no remainder. So we add x power 5 plus 2 x power 4 plus 6 x cubed plus 12 x squared minus 27 okay, that's 7, not look like a 7, so we'll write that again. 27 x, and then finally minus 54. Okay, so we have x to the power 5 plus 2x to the power 4 plus 6x to the power 3 plus 12x to the power of 2 minus 27x minus 54. So to complete long division, we have to think about what can we multiply x squared, so this value, to get x to the power of 5. So we can multiply this by x to the power of 3. So we can write x to the power of 3 above. And then we can, since we multiply this by x squared by x to the power of 3, we get x to the power of 5. And then we also multiply x to the power of 3 by 9. And that's what we get. And then we subtract the two polynomials. And then this will give us, so the x to the power of 5 and x to the power of 5 get eliminated. We still remain with 2x power of 4 plus, actually minus, because we have 6 minus 9, so 3x minus 3x cubed plus 12x squared minus 27x. So just the remaining of the polynomial. So just give me a second to write this down. Okay. So we figured out what the first term was in our division, and that's x to the power 3. Next, we look at this term and think, what can we multiply x squared, so this term over here, to get 2 to the power of 2 times x to the power 4. So I'll underline these two terms in red. So we're looking at this term and this term. So we know we can multiply x squared by 2x squared to get 2x to the power of 4. So write 2x squared above. And then we'll subtract. So x squared times 2x squared will give us 2x to the power of 4. And then 9 times 2x squared will give us 18 to the power of x times x squared. And then we just subtract these two polynomials. So we know we get 0 in the beginning, and then we're left with negative. So I'll write this over. So we get 0 for these two. And now we get negative 3x power of 3. Then we have 12 minus 18, which will give us negative 6 x squared. And then we have the rest, so negative 27 x minus 54. So finally, or not finally, there's two more steps still. So we think about the negative 3x cubed and the x squared. What can we multiply by x squared to get negative 3x cubed? We know we can multiply by negative 3x. So we'll write negative 3x up here. Okay. And we'll do the multiplication down here. So x squared times negative 3x will give us negative 3x cubed. And we also have the 9. So 9 times negative 3x is negative 27x. And then we subtract the two functions. So we're left with 0. And then we also have the negative 6x squared. Then negative 27x minus negative 27x is also 0. And then we have 54. Finally, to find the last term, we know we can multiply x squared by negative 6, so I'll put negative 6 up here. And so negative 6 times x squared will give us negative x squared, negative 6x squared, sorry. And 9 times negative 6 is negative 54. So we can see that these just cancel out and we get 0. And we get 0 for the remainder. So we successfully divided out x squared plus 9 into this function. and we got the polynomial that we're looking for. Okay, so I'm going to erase most of this stuff so we can go on to the next thing. I'm going to leave the important information that we've solved so far. I'm just going to make this a little bigger. Okay. So we're left with this function, put it in bracket, and we'll erase this and put it up here. So we know this function is equivalent to the given function at the very beginning. We have x squared plus 9 multiplied by x cubed plus 2x squared minus 3x minus 6. So the next step we want to do is think about this part of the function and see what kind of factors we can, or what are the roots of this function. In order to find the roots of this function, we can do the rational roots test. So the rational roots test is essentially as follows. So we look for plus or minus factors of a naught. So factors of a naught, I'll just write f for factors, and then divided by factors of an. So a naught just represents the final term over here. So a naught just represents -6. An represents the coefficient with the highest power, so 1 here. And we look at what kind of numbers we get from this. So just writing these out right away. So we know for 6, factors of -6 are 1, 2, 3, and 6, plus or minus. And factors of 1 are just 1. So we're going to look for, so if we divide 1 by any of these, we'll just have 1, 2, 3, and 6, and then we have plus or minus. To find a root of this function, we're going to substitute 1 at a time. So we'll substitute 1, -1, +2, -2, -2, +3, -3, +6, -6. And then whichever one gives us this function equivalent to 0. So if we substitute that value and we obtain a 0, that is one of the roots of that equation. So we can start off with, let's say we can start off with 1. So if we substitute 1, so let's call this function f at x. So we'll say this is, just erase some of the mess over here. So we'll call this f at x. And we'll evaluate for these values. So let's say f at 1. You can plug this into your calculator to make it a little easier, but we can also do some mental math. So 1 cubed is just 1, plus 2 times 1 squared, which is just 2. So 1 plus 2 we have so far, minus 3 times 1. So 1 plus 2 minus 3 minus 6. So 1 plus 2 is 3, minus 3 is 0, and then -6. So this gives us -6. So we know +1 is not a root. We can also try other values, and if they give us something other than 0, then we know it's not a root. Let's try -2. You can also try -1. And +2, but I know -2 for this function will work. So if we substitute after the -2, -2 cubed is just -8. So 2 times -2 squared. So we know -2 squared is +4 times 2 will give us +8. So whenever we cube a negative number, we'll get a negative number, but if we square a negative number, we'll get a positive number. And then we have negative 3 times negative 2, which is positive 6. And then lastly, minus 6. So we know the 6's cancel out, the 8's cancel out, and we're left with 0. So we know x equals to negative 2 is a root of this function. We'll clear the board out a little bit. Okay, so we know that x minus plus 2 actually. So x equals negative 2, therefore what we can factor out is x plus 2. So there's the positive sign instead of the negative. So, but we know x minus 2 is one of the roots. This is how you just represent it when you're putting it in the function. So we can use this to do synthetic division on the function. So to do synthetic division, I'll go through the steps one by one. So you place all the coefficients of this function on top. So I'll say 1, 2, negative 3, and negative 6. And then we'll put the root over here for negative 2. So the first thing you do is you bring down this value, and we'll write it down here. Then we'll multiply 1 times negative 2, and the result of that is negative 2, and we'll write it over here. Then we add 2 plus negative 2, and that will give us 0. And then we do negative 2 again, times 0. And that will give us 0. And then we add negative 3 plus 0. This gives us negative 3. And then finally, we do negative 2 again, times negative 3. And then this gives us positive 6. And then we add negative 6 plus positive 6 will give us 0. So we get up, this value represents the remainder, so the remainder is 0. And we know that we're left with x squared. So this column represents x squared, this represents x, and this represents just the constant. So we know x squared plus 0x, which is just 0, minus 3. That's the solution for dividing x plus 2 into this function that I have underlined up above. So far, when we factored out for our equation, we have x squared plus 9. We have x plus 2. And we also have x squared minus 3, which is what we solve for right now. So the question is asking us, we need 5 linear polynomials. So we need to have all exponents to the x to the power of 1, so no x squared. So to simplify this even further, we know x squared plus 9 represents the roots positive and negative 3i, so we can say x minus 3i. And then we also have x plus 3i. And we have x plus 2, which is in the correct format. and then multiplied, so dot for multiplied. So I'm just continuing on from over here. I'm just going to put the rest down here. So we have x squared minus 3. So x squared minus 3 is a difference of squares as well. We know to solve for this, we'll end up x minus square root 3. We know square root 3 squared is just 3, which is this value, and then x squared is just x, so this is just the equation for difference of squares. And then x plus square root 3. And that's the final equation for the solution. So we expressed the equation as a set of 5 linear polynomials. Linear just means that x will be to the power of 1. So each part of the equation is the x to the power of 1. So we have 5 roots. We have x is equal to plus or minus 3i, x is equal to plus or minus square root 3, and x is equal to negative 2. So let's look at the solution here to verify. So first, because it is root. Okay, so this is an incomplete solution. So incomplete solution correct answer is x plus minus 3i, x plus 3i, x plus 2, x minus square root 3, and x plus square root 3. And the solution is incorrect. Okay. So thanks for joining this session. That's all the questions we have time for this session. If you learned something along the way, you can always visit oneclass.com for your tutoring and homework help, or you could visit the link in the description to look at the other services that OneClass provides. Hope to see you next time for another math session.